By late 1925, the idea of building a new Soviet aviation engine with 100 horsepower was finally starting to take real shape. To pick the best option, they organized a special competition, and two main contenders emerged. The first was the M12 engine, developed by a team of engineers led by designer Mykola Romanovich Brilling. The other contender was a motor called the M11. It was designed by a young engineer named Arkady Shvetsov. At first, the M11 engine was leading this back-and-forth race. It was the first to successfully pass preliminary bench tests, but then an unfortunate breakdown occurred. Because of this, the lead temporarily shifted to its direct rival, the M12, but the engineers on both sides refused to give up and kept refining both motors. Depending on which one was showing better results at any given moment, the authorities kept changing their minds throughout 1926. The contract for the new training aircraft kept bouncing back and forth between the M11 and the M12. By the end of the year, this indecision had frustrated everyone so much that they seriously considered just slapping a reliable 120 horsepower German Maybach engine onto the plane. And in early 1927, two more foreign motors entered the mix: the Lucifer at 100 horsepower and the French Samson at 120 horsepower. Rather than diving deep into this tangled saga of engine selection, let's just say this. By late April 1927, the aircraft designers finally received the first experimental prototype of the M11 motor. That was the one they decided to install on the new U-2 training aircraft, which was being actively built at the time. Although doubts about this choice lingered even into 1928, the final decision was made. The M11 engine went into mass production at a factory in Zaporizhia. Meanwhile, the U-2 project itself, which had been stalled since 1923, finally got moving. In the middle of summer 1926, engineers in Moscow received clear, updated technical requirements for this training aircraft. The man put in charge of this project was 34-year-old designer Mykola Mikolayovich Polikarpov. When he started the work, he built on existing blueprints and work from other Soviet aviation engineers. In just 3 months, the preliminary design was fully complete, and by December 1926, it went before a review board. The proposed design satisfied the military and the toughest critics. The main requirement for further development was maximum simplicity of maintenance and, of course, absolute flight safety. The fuel tanks were placed in the upper wing, closer to the center of the fuselage, because engineer Andrei Mikolayovich Tupolev personally insisted on it. Once the basic concept was approved, work kicked into high gear. And by January 18, 1927, the preliminary aircraft design was fully complete. So what did the first U-2 look like? It was a classic biplane built entirely from wood. It had fairly simple, almost rectangular wings and tail surfaces. This straightforward design wasn't accidental. The main goal was to make production cheap and field repairs simple, which also made many parts interchangeable. For example, the detachable wing sections were absolutely identical, and the control surfaces on the wings could be easily swapped onto the tail and vice versa. This made the aircraft incredibly practical. The wing used a thick airfoil, 14% relative thickness. In the spring of 1927, thorough structural testing began. They lasted over a month, and by summer of that year, the results were formally accepted by military command. As soon as the static ground tests were completed, the aircraft was prepared for the most critical phase, actual flight. In mid-June, it was rolled out onto the runway for the first time. After several attempts to start the rather temperamental engine on June 24, 1927, test pilot Mikhail Mikhailovich Gromov lifted this training aircraft into the sky for the very first time. After landing, Mikhail Mikhailovich Gromov reported that the U-2 was well suited for its intended role. According to him, he'd wrung out every last bit of performance this aircraft had to offer. However, further test flights of the first experimental prototype often had to be postponed. The reason was, once again, that same problematic M11 engine. The oil kept overheating, and when the plane climbed to altitudes between 3,300 and 4,900 feet, the engine started acting up badly. Only through persistent teamwork among the engineers did they manage to overcome all these teething problems by mid-August. Factory trials were successfully completed in early September 1927. After that, the aircraft was transferred to the Air Force Scientific Research Institute, where it was thoroughly tested until October 20th. The new machine met nearly all military requirements, with one exception, its rate of climb. Despite this, they decided to produce an experimental batch of U-2 aircraft with the M11 engine. But then something unexpected happened. The chief designer Mykola Mikolayovich Polikarpov himself pushed back against the decision. As it turned out, he had been secretly working on blueprints for a second version of the U-2 since late summer. In this updated version, he incorporated numerous successful solutions from his earlier P-2 model. The aircraft's design got a major overhaul. The engineers managed to reduce the overall weight and give the plane smoother, more aerodynamic lines. At the same time, at the military's request, the wings were made significantly stronger. Rather than relying on elaborate testing, the designers simply switched to a thinner, more efficient wing profile, which solved the main problem, the slow rate of climb. Now the updated U-2 fully met the strict standards and could climb to an altitude of over 6,500 feet in just 13 minutes. The second prototype was built remarkably quickly, but its appearance on the runway was delayed. The aircraft was simply waiting for its engine to be delivered. The first M11 engine prototype was sent back to the aviation factory, where it was reworked to fix all the problems they'd found and rebuilt from scratch. If we trust the official correspondence from that period, the second experimental U-2 was delivered to the airfield on January 16, 1928, and just a few days later it lifted off the ground for the first time. However, there's a real mystery surrounding the date of this historic first flight. Aircraft designer Vadim Borisovich Shavrov wrote some fascinating recollections. He wrote that in the 1950s, aviation historians found it incredibly difficult to pin down the exact day when the final version of the U-2, the one that would go on to become a widely mass-produced aircraft, actually took to the sky. No official documents could be found in the archives. All that was known was that it happened somewhere around the turn of 1927 and 1928. Even test pilot Mikhail Mikhailovich Gromov couldn't recall the exact date. The answer turned up completely by accident in one of Mykola Mikolayovich Polikarpov's personal letters. It contained this phrase, "On Christmas Day, the Lord sent me joy." A successful flight of the new aircraft took place. Since he was referring to the Orthodox holiday, this clearly points to January 7, 1928. During the factory trials, Mikhail Mikhailovich Gromov personally tested the U-2 for control response and its ability to perform aerobatic maneuvers. The results were positive. The aircraft handled all the required maneuvers cleanly. It entered a dangerous spin very reluctantly, but recovered from it remarkably easily. Exactly what you want in a plane students are going to learn on. Since Gromov was working part-time, he didn't write up the official report right away. State trials were successfully completed in March of the same year. This training aircraft had a takeoff weight of about 1,920 pounds, and the wing loading was just over 5 pounds per square foot. In the air, it could reach a maximum speed of 87 miles per hour, while its landing speed was just 37 miles per hour. Thanks to these specs, the U-2 met all military requirements. Pilots responded positively, and the decision was made to launch mass production. In the fall of 1928, this same second experimental U-2 prototype was sent to Berlin for the International Aviation Exhibition, which opened on October 7th. It was a notable moment as it marked the first time Soviet aircraft were shown to an international audience. Besides the U-2, the Soviet pavilion featured the K-4 medical evacuation aircraft designed by Konstantin Oleksiyevich Kalinin, the long-range reconnaissance aircraft R-3, also designated ANT-3, as well as small light aircraft, the Petrel by Viktor Pavlovich Nevdachin, and Three Friends, created by Serhiy Mikolayovich Horolov, Alexander Alexandrovich Semenov, and Lev Ivanovich Sutuhin. The main production site for the U-2 was one of the Leningrad aviation factories, which already had years of experience assembling training aircraft. The plans for 1929 called for producing 70 brand new U-2s while winding down production of the outdated U-1 model, of which only 50 were to be built. But the reality of production was far from ideal, as aircraft designer Alexander Serhiyovich Moskalev, who worked at that factory at the time, recalled, serial production of the U-2 started in utter chaos. The factory had neither a complete set of working blueprints nor accurate strength calculations for many components. Workers had to assemble the first production aircraft by looking at a finished prototype, and sometimes by simply relying on their own memory. Alexander Serhiyovich Moskalev recalled a time when he and his colleague, engineer Ole Mikolayovich Rozanov, had to personally put together all the necessary technical documentation for the new aircraft. They worked around the clock to get it done. Just picture this: a massive factory had only 2 engineers handling all the complex calculations. They had to keep up with the breakneck pace of production while handling problems no one had planned for. By late 1928, a new training aircraft had appeared. The U-2, created by designer Mykola Mikolayovich Polikarpov. It went into mass production to fully replace the outdated U-1 model. But once again, detailed technical calculations for the new aircraft were lacking. On top of that, the design itself kept being modified on the fly, adapted to the realities of production at the time. So Moskalev and Rozanov had to recalculate all the aerodynamics of the U-2 from scratch and verify the structural integrity of its airframe. In fact, the very first thorough and comprehensive analysis of this aircraft was done by these 2 engineers. In the beginning, the U-2 didn't even have a basic parts list. Since there was simply no one else to do it, they took on this tedious work themselves. Financial incentive played a role too. The task was to precisely determine the dimensions, weight of each part, and the metal blanks needed to make them. Back then, this meticulous work paid reasonably well. About 30 kopecks per line in the document, since the accounting department had an incredibly hard time figuring out standard rates for such an unusual task. The engineers worked overtime, staying up late into the night. Over time, they got so good at it that they managed to earn what was, by the standards of those days, a small fortune, several hundred rubles. The first production U-2 started arriving at flight schools in 1930. Despite certain technical shortcomings, the aircraft won praise from experienced instructors and complete beginners alike. The training process on this machine turned out to be remarkably effective. Thanks to its easy handling, fewer cadets washed out for lacking flying aptitude. By the end of the year, the aviation factory had produced 150 of these training machines. Most of them had entered service with the military by early 1931. After that, the production pace only picked up. In just the first 3 years, roughly 1,400 brand new U-2s rolled off the assembly line. This made it possible to almost completely phase out the old, worn-out U-1 biplanes from military and civilian flight schools, and some of the aircraft were handed over to local aero clubs for youth training. The Civilian Aviation Authority at the time had 3 large pilot training schools, which received several dozen U-2s. But the lion's share of machines went to the military. By early 1933, they were actively using nearly 600 of these aircraft for training. The machines from the early production years caused plenty of headaches for the ground crews. The engine mounts and landing gear shock absorbers were too weak and broke frequently. Engines overheated quickly, metal cowlings cracked from vibrations, and fuel system sealing issues even led to occasional in-flight fires. But despite all these technical problems, pilots described the aircraft as highly responsive and easy to fly. At relatively low engine revolutions per minute, the U-2 climbed effortlessly. After just the second turn in the pattern, it would be up to nearly 980 feet. The U-2 could easily execute steep banks up to 60 degrees without losing altitude. Meanwhile, at the factories, they kept continuously improving the U-2's design, trying to cure all its growing pains. Step by step, engineers installed more comfortable crew seats, reinforced the lower wings, enlarged the windscreens, and increased fuel tank capacity. New gauges appeared on the instrument panel, including a fuel level indicator. Though it did have one amusing flaw: if the pilot performed a loop and the aircraft hung upside down, gasoline from the gauge would pour right into the front cockpit. All these useful improvements caused the aircraft to gain roughly 45 to 65 pounds. It might not sound like much, but you could feel the difference. Pilots who had flown the earliest, lighter models immediately felt it. The newer versions seemed slightly sluggish and less agile in the air. But as U-2s flooded into military flight schools and the approach to pilot training evolved, a new direction emerged. This originally pure trainer would also be adapted for actual combat missions. Specifically, this involved training crews for bombers and reconnaissance aircraft. The older machines previously used for this, such as R-1 aircraft with BMW-4 engines and the handful of P-2s, had completely worn out and were frankly obsolete. So in 1933, one of the aviation factories began producing a military variant of the U-2. These machines were additionally equipped with a forward-firing machine gun, a rear defensive gun, and special bomb racks. Over time, aircraft of this type were repeatedly upgraded and modernized to meet evolving requirements. For example, the updated 1937 model U-2s had a fixed forward-firing machine gun on the left side of the fuselage and a flexible machine gun for the observer in the rear cockpit. Bomb racks for small aerial bombs were located under the fuselage. A bomb sight was mounted on the right side, and to give the pilot a better view for aiming, a special cutout measuring roughly 2.7 by 11.8 inches was even made in the lower right wing. Out of all the machines built at the Leningrad aviation factory through 1938, about 600 were these military U-2 variants. However, it would be a stretch to call these aircraft a real combat force when the war with Germany began. First, nearly all of them were heavily worn out by that point. Second, their armament was seldom used and only fitted temporarily. By the late 1930s, a truly enormous number of Polikarpov's trainers were flying across the country. According to official figures from October 1940 alone, the military aviation training fleet included over 3,500, precisely 3,424, U-2 aircraft. On top of that, another 384 U-2 training aircraft were in service with the Navy. But the most important role these machines played in the pre-war period was in training future pilots through the nationwide network of civil defense aero clubs. While in the early 1930s, flying was taught only at a few specialized schools that required cadets to leave their regular jobs entirely, the approach changed radically over time. By the mid-1930s, most of the old flight schools were simply shut down, and instead a vast network of aero clubs was rapidly set up across the country. The slogan of the era, "Young Communist, Take to the Skies," was part of a massive state-driven mobilization campaign aimed at urgently training 100,000 new pilots. From 1931 to 1936, the aircraft fleet in these organizations grew a staggering 19-fold. By 1936, the country had 150 aero clubs in operation, and in 1935 alone, they graduated 8,000 trained pilots. Aviation festivals and air shows, organized as annual state events since 1933, were used to promote this push among young people. But peacetime was rapidly running out. Just 1 month after Germany invaded the Soviet Union on July 23, 1941, the main aviation factory was ordered to evacuate to the city of Kazan, away from the advancing front lines. The first trains carrying machinery and materials headed east in late July, and the last 9 aircraft were assembled in Leningrad in August. The situation at the front was deteriorating by the day. On August 20, 1941, German forces captured the key station of Chudovo, cutting the route to Moscow. And on August 29th, the station at Manga fell, which completely cut off rail traffic to the northeast. Before that fateful moment, 8 trainloads of factory equipment and 3 more trains carrying high-quality timber for aircraft construction were evacuated from Leningrad just before the encirclement was complete. At the new location in Kazan, production of the U-2 was set up at a local facility. This factory had a rather interesting history. It had previously manufactured horse-drawn wagons and carts, which is why people called it the wagon shop. Later, starting in 1935, it began producing skis for aircraft, and just before the war, it was making wooden components for I-153 and Lei GG-3 fighters. The long-term plan had been to use the facility for assembling military gliders. By government order in mid-August 1941, the evacuated Leningrad factory and the local Kazan plant were merged into a single consolidated enterprise. Almost immediately after the evacuated workers arrived, the factory quickly pivoted to producing equipment for the war effort. On September 2nd, the first U-2 fully assembled at the new Kazan facility successfully took off on its maiden flight. The factory's early days were accompanied by every hardship that war could bring. Workers were desperately short of basic materials and components. Specialized aircraft lacquer and casein glue had completely vanished, and without them, production seemed impossible. In the fall of 1941, during the evacuation of the Voronezh engine factory, the supply of M11D aviation engines was seriously disrupted. Over time, however, many of these problems were solved. Designers found substitutes for scarce materials and streamlined the assembly process, cutting the amount of non-ferrous metal used per aircraft by nearly 86 pounds. That same fall, aircraft designer Mykola Mykolayovich Polikarpov visited the factory. He personally appointed Georgy Ilarionovich Bakshayev as the U-2's chief designer. This didn't just mean minor tweaks, it meant developing entirely new military variants of the biplane. Starting in 1943, the factory began actively implementing assembly line methods for building fuselages, which accelerated the production of new machines considerably. To give you a sense of the scale, while building a single U-2 previously took about 3,000 hours of painstaking work, at the height of the war, that time was cut down to just 1,215 hours. Among the notable innovations that year was the addition of extra fuel tanks in the center section of the wing, which held about 13 gallons of fuel. In 1944, the modernization went even further. The small wing tanks were eliminated in favor of a single large tank holding over 53 gallons in the fuselage itself. For defense, engineers mounted a new flexible turret for the Degid-Yaryov DT machine gun, giving gunners a much wider field of fire. A flare gun and an updated NPU-2 bomb sight were also added. Alongside combat aircraft production, the factory also began manufacturing spare parts for tractors and other agricultural equipment that same year, helping to support the home front. And starting in August, the aircraft received its new, more widely recognized name, Po-2. The story of its heart, the M11 engine, is a whole separate saga spanning many years. The main goal of every engineering effort was simple: to squeeze out more power. The chief designer at the engine factory, Mikhail Alexandrovich Kosov, in his attempt to improve the base model, essentially built a brand new engine based on it, designated the M12. This was already the second motor to carry that name, but it had absolutely nothing in common with the earlier engines that shared it. This new M12 engine, built in 1942, produced between 190 and 200 horsepower and inherited a fair number of parts from its predecessor. According to the documentation, nearly half of its components were carried over from the old motor, and in the slightly newer M12A modification, that share was about 1/3. But there were plenty of significant differences too, differences you could spot just by looking at it. The engineers changed the valve timing system, and because the motor was more powerful and ran hotter, the cooling fin area on the cylinders had to be increased by more than 50%. In the summer of 1943, they ran extensive 100-hour trials on one of the experimental M12 prototypes, fitted with a new K12 carburetor. The results were encouraging and passed the commission's review. After that came a long phase of minor refinements, during which about 10 more test engines were built. One of the production U-2 aircraft fitted with this new engine successfully logged 75 flight hours by October of that same year. The refinement process continued throughout the following year as well. Thanks to this new power plant, the U-2's flight performance improved dramatically. The aircraft could now climb to altitudes exceeding 16,400 feet. It climbed a third faster, and the takeoff run was cut by a quarter. Yet this promising M12 engine never made it into mass production. All the best ideas from its development were carried over into other, more advanced engines, such as the M11FR1 and the M11FR. As for how the U-2 was actually built, it was remarkably simple. The aircraft was built primarily from pine and plywood, with the frame covered in ordinary fabric. Connecting fittings were made from mild steel. The interplane struts were originally made from expensive teardrop-shaped duralumin tubes. But to make production cheaper, these were quickly replaced with ordinary round steel tubes, to which wooden fairings were attached with glue and tape for better aerodynamics. The forward fuselage was skinned in plywood, while the tail section was braced with steel wire. The top of the rear section was covered by a removable panel made from very thin plywood, just 0.04 inches thick. This allowed mechanics to easily remove it and inspect the aircraft's internal components. The engine mount in the early versions was a solid ring stamped from duralumin, about 0.16 inches thick. But by the early 1930s, it was replaced with a sturdier, all-welded construction of steel tubes. This idea was borrowed from another aircraft, the Sh-2, which had previously been assembled at the same factory. The wings had a classic, time-tested structure built around a sturdy wooden frame. Instead of complex and heavy metal alloys, they used plywood and wooden strips, which craftsmen carefully joined together using ordinary nails and special glue. This made the machine very easy to build and simple to repair in the field. The tail section was also carefully designed. The stabilizer's angle of incidence could be easily adjusted on the ground before flight by simply repositioning the attachment points. To ensure the structure could handle aerodynamic loads, the wing and tail tips were reinforced with lightweight but strong duralumin, and support came from adjustable-length steel tubes. The landing gear was built to handle the harshest operating conditions. Shock absorption relied on telescopic tubes wrapped tightly with half-inch rubber bungee cord. Just imagine, each strut required over 52.5 feet of the stuff. The aircraft sat on spoked wheels measuring roughly 27.5 by 4.7 inches, and at the rear was a steerable wooden tail skid made of ash, which helped with ground maneuvering. In winter, the wheels were swapped out for heavy skis. The main ones measured approximately 86.6 by 13.1 by 10.4 inches, and the tail ski was 19.7 by 8 inches. The aircraft's controls operated through a reliable system of steel cables and wires. The evolution of the engine cowling was particularly interesting. Originally, the motor was completely enclosed under a solid cowl, but they eventually abandoned this idea, leaving most of the engine exposed for better cooling. The new cowling consisted of 4 separate panels held together by a special cable with a latch. Thanks to this simple solution, mechanics could open or close the engine almost instantly, which saved an incredible amount of time during repairs and maintenance. Only in the dead of winter was the engine sometimes covered with extra panels. Over the many years of active service, countless small improvements were made to the design, driven by extensive real-world experience. The U-2's flight characteristics varied depending on the equipment installed and what missions it was being prepared for. The aircraft built a consistent reputation for reliability and was light and responsive to the controls. The U-2 could take off and land on tiny patches of ground. It didn't even need a real airfield. Just about any flat clearing would do. As for the numbers, the empty aircraft in its training configuration weighed about 1,400 to 1,446 pounds, while other variants went up to 1,653 pounds. Takeoff weight ranged from 1,962 to 2,425 pounds, though with a full combat load and bombs, the machine could weigh over 3,086 pounds. The speed figures weren't going to turn any heads, but they perfectly matched the aircraft's missions. Maximum speed reached 81 to 93 miles per hour, cruising speed held at 62 to 75 miles per hour, and the U-2 touched down at an incredibly low 37 to 43 miles per hour. The aircraft could climb to altitudes up to roughly 9,800 feet, and it only needed 328 to 492 feet of runway to take off or land. That's all for today. If you found this video useful, consider subscribing. It helps the channel grow. See you in the next one.